Assalamu alaikum everyone. Welcome to today's exciting science activity. I am going to show you the mysteriously moving needle experiment. A swing needle that moves on water without being touched. Through this experiment, you will learn how a needle becomes temporarily magnetized, how magnets interact through invisible magnetic field lines, how magnetic force causes motion without contact. This activity also connects with your following SLOs: magnetizing and demagnetizing magnetic materials, properties of magnets and their everyday uses, types of magnet, magnetic fields around magnet. Let's begin to perform this experiment. For this experiment, you will need a bar magnet, a swing needle, a styrofoam, a ball with a little water, and a magnet placed in it. First, we make the needle magnetic. Take a strong bar magnet, rub its north pole along the head of the needle many times. You must be wondering what is happening inside the needle. The tiny magnetic particles inside begin to line up. The end you rubbed becomes the north pole and the opposite end becomes a south pole. So now your ordinary needle becomes a temporary magnet. Why don't we rub the pointed end? Because the tip is thin and sharp. It does not magnetize as well. Rubbing the thicker head gives stronger magnetization. Now carefully place the needle on the surface of still water. You may place it on a small piece of cork or styrofoam so it can float easily. Now, something interesting is about to happen. See, the needle moves toward the south pole of the magnet. It moves away from the north pole of the magnet. Why does it happen? Because like poles repel and opposite poles attract. The invisible push and pull makes the needle move without touching it. You may notice the needle does not travel in a straight line. Instead, it curves. This is because the needle is following the magnetic field lines of the bar magnet. Magnetic field lines curve out from the north pole, bend and enter into the south pole. The needle simply follows these curved invisible lines. As the needle comes closer to the magnet's poles, it moves faster. That's because the magnetic field is strongest near the poles. Other things that affect speed are strength of the needle's magnetization, strength of the bar magnet, smoothness of the water, distance between magnet and needle, friction from cork or styrofoam. So this moving needle is not magic, it's a magnetism in action. Once magnetized, the needle behaves like a tiny magnet and responds to the invisible magnetic field around it. Now, use these questions to check your understanding. What will happen if the needle is not magnetized? What changes if we rub the needle in the opposite direction? Is Earth's magnetic field affecting the experiment? Why or why not? How can we find the north and south poles in children's magnet? Thank you for watching. Don't forget to try this experiment at home and share what you observe. Allah Hafiz.